Okay, here's an example. Talking about a spring and Hooke's law. And what it tells us is that the total length of a certain spring can be modeled by L equals 0.3W plus 5, where L is the total length in inches, W is the weight in pounds. First thing it says is find the inverse. So I'm only going to focus on that portion right now. Now this one, it's not X and Y anymore, but we still follow the exact same process. So instead of having an X here, I have a W. Instead of having a Y, I have an L. So I'm going to solve this equation for W. So I will end up with L minus 5, had to subtract 5 from both sides, divide by 0.3, is equal to my W. This time I am not going to switch the variables. And the reason for that is my variables have meaning right now. Before, when we were doing these examples, the X and Y's didn't have any specific meanings. W and L have very specific meanings. And if I change them, I will actually be changing the context of my problem. So I'm going to leave W as W because it stands for weight. And I'm going to leave L as L because it stands for our length. So this is one of those examples where I'm not going to switch my variables around. So that takes care of the first part of the problem. Second part says use the inverse to find the weight of an attached object if the spring has a total length of 11 inches. Well, my length of 11 inches goes right in here for L. So I would end up doing 11 minus 5 divided by 0.3 is equal to my W. Now when you're doing this type of problem, you have to do the top of the fraction first. So you would do your 11 minus 5, which would give you 6. Divide that by 0.3, and we get W is equal to 20. So that would tell us whatever item we have on here would have been 20 pounds. Okay, the last thing we need to talk about is sometimes we need to deal with restricted domains. So I've put the graph y equals x squared right up here. It's just our standard parabola, and its inverse would be, well, in order to get x by itself, I need to do the square root. Since I'm applying the square root, it would be plus minus, and then switch your variables x and y around. Here's the graph of the inverse. Now, if I asked you, before I put the inverse up there, whether these were going to be inverse functions, I hope you would have said no, because this original would not have passed the horizontal line test. It would have touched the parabola in 2 spots in many places. So I could have told you that our inverse was not going to be a function. And see how our inverse fails the vertical line test? So the inverse is definitely not a function. Well, sometimes we need to be working with functions. So what we can do is we can restrict our domain. Now when we go and we restrict our domain, we have to think about where is our function cut in half, basically. And for this particular one, our axis of symmetry is right where x is equal to 0. And usually we want to work with the positive half, so I'm going to restrict my domain to when x is greater than or equal to 0. So what happens is I will only be looking at half of my graph. Since I've restricted my domain, this is the only part of the function I'm looking at. This other side no longer is there because I don't get to use those values. Now what happens when I restrict my domain of my original function, you have to realize that my inverse has a restricted range, because remember, your domain of your original becomes the range of the inverse. So the domain of f of x becomes the range of f inverse. What that means is my range is going to be greater than 0. My range is my y value, so I'm not going to end up having any of these values down here. Once I get rid of that portion of my graph, now I actually have functions because I have a restricted domain. Okay, here are some practice problems. Go ahead and pause the video and see what you can come up with for these. Okay, on this first one you should have came up with y equals plus or minus the square root of x plus 9 all divided by 5. And if you write it in inverse notation, you would have had f to the negative 1 of x equals that quantity. So either one of those would be all right. Second one. Hopefully you noticed I named this one g. So you would have g inverse of x is equal to the cubed root of x plus 7 divided by 6. Now with odd roots, we don't need the plus minus. And the third problem, I did f of g of x first, and when I plugged that in, I had this squared on the outside of the parentheses, so I had to FOIL first. Then I multiplied throughout the 4, simplified what I could, and I ended up getting 0.25x squared minus x plus 3. Now in order for these to be inverses, I would have had to get just an x. So I didn't need to go any farther. I got no. You could have also started with g of f of x for that particular one. And you still eventually would have ended up to the same answer of getting no.